Assalamu alaikum everyone, welcome to Mathematics with Shahab Yaqub. In today's class, we are focusing on this differentiation question that is from May-June 2019, variant 33, question number 4. Now let's start underlining the question. The equation of a curve is y equals to 1 plus e raised to power of negative x divided by 1 minus e raised to power of negative x for x is greater than 0. Show that the gradient function dy by dx is the gradient function is always negative. Now let me use some sticky notes over here to write down the necessary details related to this question. The first thing is we are dealing with a quotient. So let me write down y is equals to u over v, where u is the numerator and v is the denominator. So therefore dy by dx, the derivative is v u prime minus u v prime, the whole thing divided by v square. So what is u over here? U is 1 plus e raised to power of negative x. And what is v over here? The denominator, 1 minus e raised to power of negative x. Differentiate, and the next thing that I need is the differentiation thing. Y is equals to e raised to power of ax plus b. Therefore, dy by dx is a comes down, e raised to power of ax plus b. That means the derivative of the power comes down and multiplies. So coming back to u prime, that is negative e raised to power of negative x. V prime, this negative was there, e raised to power of negative x, which will become positive x. So now let me start focusing on v and u prime first. So therefore dy by dx is equals to minus e minus x, use brackets as much as possible, 1 minus e raised to power of negative x, and then there is a negative sign, that's part of the bracket, that's part of the formula. And what else do we have? Now let me use another color, that is u and v prime, they will multiply. So this is the blue thing and this is the reddish thing. So now over here we are multiplying these two. So this negative becomes positive. That is positive e raised to power of negative x and 1 plus e raised to power of negative x. Now it's very common that people tend to forget that there is a division sign also, and that is v square. So this is 1 minus e raised to power of negative x, the whole thing square. Now what more needs to be done? We should take something common out. So I can take e raised to power of negative x. I can take e raised to power of negative x common out. And this negative that was becoming positive. So keep that in mind. This negative, let me use the highlighter. This negative and negative became positive. And this minus sign over here, that is this minus sign over here. So do not mix up the minus sign, and it's very common to mix it up. So now if I take common, let me highlight the right one. I just saw E and I highlighted it. Hold for a second. So let me just remove this one. And this is the E thing that we are taking common. So that was my bad. And the correct color, that is e raised to power of negative x. So now if I take common, what am I left with? So I am left with e raised to power of negative x is taken common. This minus remain. So this is minus 1 plus e raised to power of negative x. And then we have this minus sign multiplying with these two. So this is minus 1 minus e raised to power of negative x divided by 1 minus e raised to power of negative x, the whole thing square. Now, are there any terms which will cancel out? E raised to power of negative x minus e raised to power of negative x, this can cancel out. And I'm left with this negative 1. I'm left with this negative 1. So that is negative 2 e raised to power of negative x divided by 1 minus e raised to power of negative x, the whole thing square. This is dy by dx. Now someone could have also said that could we have taken this negative common out? The answer is yes. Yes, you can definitely take it common out. It depends on how much simplification do you want to do initially or do you want to do it later. It's just a matter of choice. So if I double check all my working, Show that dy by dx is always negative. This is u prime, this is v prime, applying the quotient rule. So let me write over here, this is the quotient rule that we have applied. That is vu prime minus ub prime over v square. So all this thing is applied. The minus is taken common, the exponential is taken common, everything is done. Now comes the next part. Show that it's always negative. So now e raised to power of negative x, it is always positive. E raised to any power is always positive. And then 1 minus e minus x, 1 minus e raised to power of negative x, the whole thing square. Again, by the same token, this is always positive. And overall, even if it's negative, because of the square, it will always be positive. So there is a positive numerator, there is a positive denominator, dy by dx is negative into a positive thing divided by a positive thing. Now what is happening because of the minus sign? Because of the negative sign, whatever is the value of x for positive values, dy by dx is always gonna be negative. So now we are on the second part. And now the question says, let me start underlining it. The gradient of the curve is equal to -1 when x is equals to a. Show that a satisfies this equation. Hence find the exact value of a for 4 marks. So now what we can do is that, let me write dy by dx again. And if I am not mistaken, dy by dx is -2 e raised to power of negative x over 1 minus e raised to power of negative x whole square. Now let me insert the value x is equals to a. That is what I want to plug in, so that the gradient value is equals to -1. So therefore -2 e raised to power of negative a divided by 1 minus e raised to power of negative a whole square equals to -1. So now let's start working. First of all, get rid of the negative sign. That is the very first thing that needs to be done. Second thing, 2e negative a equals to 1 minus e raised to power of negative a, the whole thing square. Since they ask for the answer with a positive index, so let me convert it using indices. So when I use indices, I can write a raised to power of negative m as 1 over a raised to power of m. So this is 2 over e raised to power of a 1 minus 1 over e raised to power of a, the whole thing square. And let me also use a minus b whole square, which is a square minus 2ab plus b square. So this is 2 over e raised to power of a, 1 square is 1, minus 2 over e raised to power of a plus 1 over e raised to power of 2a. A raised to power of m raised to power of n, that is a m n. E raised to power of a raised to power of 2 is e raised to power of 2a. So let me also highlight the stuff that's right over here. And let me also highlight this basic algebra. So these are all the background things that we need. So now what I'll do is that I'll multiply both sides of the equation by e raised to power of 2a. So let me write it out. 2 over e raised to power of a multiplying with something, 1 it's multiplying with something, minus 2 over ea is multiplying with something, 1 over e raised to power of 2a is multiplying with something. What is that something? That is e raised to power of 2a, that is e raised to power of 2a, e raised to power of 2a, e raised to power of 2a. First of all, these two will cancel out completely and I'm only left with a 1. Over here, this 1 will multiply with this. What about over here? This is e power a and there are 2 e power a. So this whole thing will cancel out and I'm left with e raised to power of a. Similarly, e raised to power of a will cancel out. I'm left with e raised to power of a. So this is 2e power a. This is e power 2a. This is negative 2e power a. And this is 1. And let's take to the other side. This is actually make it 0. This is e raised to power of 2a, negative 2, negative 2. That is negative 4 e raised to power of a plus 1. Is that the equation? Yes, so far so good. We have reached till this point. Now realize the fact that this is a disguised quadratic equation. Whatever you have studied in P1, that whole knowledge will be used over here. So let me make a substitution. Let m equals to e raised to power of a. Therefore, m square is e raised to power of 2a. So therefore, m square minus 4m plus 1 equals to 0. And I think I have to use the quadratic formula. So therefore, a is 1. The coefficient of x square or m square is 1. b is negative 4. c comes out to be 1. Let me first evaluate b square minus 4ac. That is negative 4 whole square minus 4 into 1 into 1. 16 minus 4 is 12. And let me draw a line in the middle for separation. And let's proceed. So therefore, x or m equals to minus b plus minus b square minus 4ac, the whole thing divided by 2a. So m is equals to minus of minus 4, negative of negative 4 plus minus square root of 12 divided by 2 times 1. Now let me evaluate root 12. That is 4 into 3. That is root 4 root 3. That is 2 root 3. So let me write m as this is 4. This is plus minus 2 root 3 divided by 2, which becomes 2 plus minus root 3. That is m. So now the question is, what should we do with this value of m? Remember, what is m equals to? M is e raised to power of a. So let me write it down. E raised to power of a is 2 minus root 3 and e raised to power of a is 2 plus root 3. Let me scroll up and have a look. Is there any condition that they have applied? Yes, they have applied a condition that x is greater than 0. And keep in mind, over here, a is that particular value of x. In other words, a has to be positive. Now, if I take ln of both sides, ln e raised to power of a is ln 2 minus square root of 3 and ln e raised to power of a is ln 2 plus root 3. So now this a will jump down, this a will jump down. This is a ln e is 1, is ln of 2 minus root 3. Over here, a is ln of 2 plus root 3. Now the question is, which is the correct answer? We know that 2 minus root 3 is a decimal. This is approximately 2 minus 1.732 and ln of a number between 0 and 1 is negative. So therefore, we have to reject this particular answer. What about this? Of course, definitely this has to be correct answer. So therefore, the final answer, the exact answer is ln of 2 plus root 3, and that is where we complete this question. So what's the moral of this particular story? That is, in this particular question, that is about differentiation. Not only have you applied the concept of quotient rule, you have applied the concept of exponential differentiation. A lot of algebra is there, a lot of positive negative sign is there, a lot of conceptual thing is there, which is about e raised to power of any number will always be positive. The denominator was positive because of the square. Because of the negative 2, it became negative. So that was the conceptual thing. And over here, even more conceptual was this idea that you have to work in positive indices. That is using this knowledge of O-level math. This is also the knowledge of indices that is used over here. Then we came across the concept of disguised quadratic equation. This is one single question that we are talking about. And over here, the concept of surds was used. Over here, the concept was used that when we look at the graph of logarithm, any value of log between 0 and 1 is negative. And finally, you get this answer. So that's from my site, Mathematics with Shahab Yaqub. Stay tuned for more content.